Hey everyone, welcome back to the channel. In today's video, I'm going to show you a vulnerable login page built with Node.js, MySQL, and Docker. This is specifically designed to demonstrate how SQL injection works and how it can be exploited. However, before diving in the actual attack demo, let me walk you through the architecture of the SQL injection lab we are building, as shown in this diagram. This is our high-level plan. We are simulating a real-world login system with a front-end, a backend, and a database, all containerized using Docker. Now, on the front-end form, right, which is this left part here. On the left, we have the login form. This is the front-end that the user or attacker will interact with. It has two fields. We have the name or the username field and the password field. Once the attacker will clicks on the submit button, the data then is sent to the backend here, or specifically to the server through a method post, and the target is slash login. That's the target. I will walk you through these two things when I'm gonna be explaining the code, because I'm gonna show the code that I have. Next, we have this. We have the backend here. This is the backend. It's made up of the server and the database. Now, in the backend, here is where the vulnerability lives. The backend is built with Node.js and Express. It accepts two types of requests: a GET request, which serves the login page, and then the POST request, as you can see here, the slash login. This is where the SQL queries run. And if you remember, I talked about the when the attacker hits the submit button, they are going to go to the slash login where everything is going to take place. Now, inside slash login, we intentionally write insecure SQL code. It takes user input and builds a query without sanitization, making it vulnerable to SQL injection. And next, we have the SQL database here. The backend talks to the MySQL. As you can see, there is a connection. The backend talks to the MySQL database. This database stores the user's credentials, usernames, and passwords. It's created using Docker. It's initialized with a simple SQL script, which I'll show you. And there are three types of users that I have included as examples, right? They are named root, guest, and Bob. And finally, as you can see down here, we have Docker, meaning that the backend, or more specifically the server and the database, are together inside the backend. The frontend is also being served inside the Docker, but I just wanted to have it like more clear this way. As for the Docker, so all of these parts, so the front end, the back end, and database, they are running in Docker containers. Docker lets us simulate this lab in an isolated and reproducible environment. So the database is one container, the backend is another one, and both containers are connected in a single Docker compose.yaml setup. So to conclude this, the user interacts with the front end here, which sends data to the Node.js backend. The backend builds a raw SQL query and talks to the MySQL database. And all of this is containerized using Docker. Here is the project folder. We have a front end for the login page, this is the login page, a backend that is built with Express and MySQL here. And everything is containerized using Docker Compose over here. So first we're going to go through the login page. This is the login page. Nothing fancy, just the usual HTML declarations, the head, body. This is internal CSS. And over here you can see the only thing is we have a login and then a form, which has the username, the password, and the button, which is submit. This is all there is for the login page. Now we have the nothing, this is nothing fancy, just a basic form. Now we have the Docker setup. So I will show you the Docker Compose. Here, so I'm running both the backend and the MySQL database in containers. The database is seeded with some user data using an init SQL, which is located here. And here's a SQL script that creates the users table and inserts some test users. So this is the table of users, and this is the users. I have those three users that I mentioned. This is creating the database, using it, creating a user, and giving them privileges over this database. But that's it. That's all for this SQL script. Now I'm going to show you the backend. The main part here is this server.js. The backend listens on port 3000, and when a post request is made to /login, it builds a SQL query, which is over here. Select all from users where the name and password. These name and passwords are the columns of our table. So yeah, where yeah this is a build. So it builds a SQL query using the input directly. This is where this grabs. Here we grab the user input for the username, and here we grab the password, and we save them in these two variables, and then we just insert these variables here. We use them. Now, this is the line that makes it vulnerable. User input is directly injected into the SQL string without sanitization. Now, I will use Docker to start the containers, and once it is ready, I will show you how it looks like. Now that it is ready to run, we just click on this here, and here is our website. Now, over here, if you remember, we had three users. We had root, guest, and Bob. So if we go with root and the password is going to be 1234, if we submit, ta-da, this is the message that's going to be displayed to us if we enter the right credentials. Now, what happens if we don't enter the right credentials? If, let's say, we enter admin, which does not exist. If we submit, we're going to get a user not found. So now we're going to perform the SQL injection demo. What we need to do here is we need to enter, so let's say we know one of the users, right, which is a root. Now we will need to enter this here, or 1 equal to 1. Now you guys might ask, why didn't I also close this other one? Well, that's because this is how I have set up the query, and this works here. So if you remember, the password for root was 1234. If I enter 12, I should be able to log in, and voila, I have managed to log in. Now I will grab the query that we have in the server side, and I will use this password to show you what's going on. So as you can see here, we have the query. This is the query from the server side. So this is the SQL statement. Now, the user will input, or the attacker rather, will input in the username. They inputted this, right? And the password, it can be whatever, 12. So this becomes like this. We have select all from users where name is equal to this, to basically root, and password equal to 12, right? Now here is how this works. we have two conditions in this statement. The first condition is where name is equal to root. So this here is the first condition, or 1 equal to 1 and password equal to 12. This is the second condition, right? So condition 1 and, oh, sorry, and condition 2. Now, what is the value of the first condition? So when root exists, right? It was a coincidence because we are a threat actor, right? Like an attacker. So we don't really have access to the usernames of a database of a system. So it was a coincidence because we know them. However, I will explain how we can perform this even when we don't know the name of a specific user. So anyway, so the first condition, this is true because the root username existed. Now for the second condition, 1 equal to 1, this is true, and password equal to 12, this is false because the password for root was 1234. So this will be false. Now we have true or false. And as you can see here from this table for the OR operator, when we have true or false, the result is true. That's why we got access. Now there is another version that we can do. So let me just copy this one here and show you how it works. So for this case, what we can do is, let's remove this condition here. So the first condition is going to stay the same. So this version here is where we don't know any username, and this version here is when we know a username. Now for this here, let's assume Anna, right? We know that it doesn't exist. So our new conditions are gonna be name Anna and this here. And what normally this here is part of the SQL query code. However, what we can do is in SQL, it depends. There are different ways for you to comment out code. But in my version, in MySQL, this here works. So if I were to add this at the end of the username field, everything that comes after this is going to be a comment. So basically, this here doesn't exist anymore. So what we have is two new conditions. The first condition is the name, which is Anna, and we know that it's false because it doesn't exist. And the second condition is 1 or 1, which is true. And false or true, which is here false or true, is true. So we're going to get access. And now I'm going to show this into the website. I'm going to display how it works. So here we are. If I add this at the end, oh, sorry, I forgot though. This is going to be Anna, right? We know that Anna does not exist. So I added this at the end, and the password is still incorrect, but it doesn't matter because the password is going to be commented out. So when I enter submit, we have a welcome root. Now you might ask, why root? Because we know that there are other users. Well, because I have made it so that if the SQL query is processed, has gone through the database, it will return the first user unless it is specified that we want another user. Otherwise, by default, it's going to return always root or the first user in the database. And there you have it. This was the how to perform a SQL injection lab that I had thought about. Now, I'm thinking about making this a 3-episode quote unquote series. This was the first one where I showed you how to perform a SQL injection. In the second one, I think I'm going to show you how we can sanitize our query so that single injection won't be able to be performed in our system. And on the third one, I'm thinking about showing you how I build this environment. Thank you so much, everyone, for whoever is watching my videos. I really appreciate you all. And yeah, this is all from me for this lab. Have a nice one.